So I have a couple other things I want to talk here about the moon. One is the craters on the moon. And we've talked about impact craters on Earth, and they pretty much work the same way on the moon. You get a meteorite or an asteroid slammed to the lunar surface. The big difference is on Earth, erosion tends to cover over the craters. Whereas on the moon, you don't have erosion. There's no wind, there's no water. Even when the moon had a thicker atmosphere than it does now, it wasn't really thick enough to do much in the way of erosion. And so pretty much when you get a crater on the moon, it stays there until later impacts. The later impacts would slam into it and eventually break down the crater because you keep smashing it with more impacts. You would toss stuff into it from nearby impacts. And then, of course, if any of your impacts crack the surface of the moon, volcanic material could flow up and fill in some of the impacts. So there are ways you can get rid of the craters on the moon, but for the most part, the craters are there, for a long time. Some parts of the moon, such as the highlands, have crater upon crater upon crater. The craters are actually touching each other, and you have younger craters that are hitting on top of older craters. The oldest craters are very difficult to see on the surface of the moon because they're pretty much blown apart by later impacts, and so that does tell you that the moon is pretty much geologically dead. Now, the seas have very few craters in them. That does not mean they have no craters in them. There are craters in the seas, and there are actually a fair number of them. So if you were to actually go to the moon, there'd be a lot of little small impacts all over there. Remember, the smaller the impacts, the more frequently they happen, and so the entire surface is covered in craters. But there are much fewer craters in the seas than there are in the highlands, which is why they look smoother. But we know the moon has been geologically inactive for a very long time. That would mean that we don't have lava flows that are currently happening, covering things up. So that would suggest that since the seas formed, there's been far fewer impacts on the moon. So from this, we can start studying the cratering history of the moon. We can look at the moon. We can figure out, how and when the craters occur by how prominent they are, by how degraded they are by later impacts. And what we find is, and we've already talked about this before, that in the earliest time of the moon's history, the period of intense bombardment. This is leftover stuff from when the solar system was forming. And so what's happened is that during that period of intense bombardment, as time passes, you get fewer and fewer impacts. Now, what was a little bit surprising was that there was a late period of intense bombardment that occurred. During the late period of intense bombardment, almost 500 million years after the solar system began, there was the second period of intense bombardment. And that is quite possibly due to, we talked about this, the clearing of the Kirkwood gaps in the asteroid belt. That tossed out all these sort of things, that the asteroids that were in the at the commensurate points with Jupiter ended up going into these basically chaotic orbits that rapidly were changing the eccentricities of the orbits, flying all over the solar system. And so what that does is that tends to cause a lot of them to fly into the inner solar system and run into things. So that's where that second period of intense bombardment may have come from. And the other interesting thing was the biggest impacts occurred near the end of the second period of intense bombardment. So that is when the seas formed. Okay, and then lava flowed in, and so that was occurring at about that time, and then since then there's been very few impacts, been just kind of a steady rain of impacts since that time. And so that is most likely due to just the occasional asteroids being tossed around. Well, one other thing I want to mention while we're talking about things being tossed around is that we had already talked about how the tidal forces between the Earth and the Moon are causing the Moon to actually recede slightly from Earth. Now, that's true. The Moon's slowly receding from Earth, and that's due to these tidal forces. Now, we know it's been doing that because when the Apollo astronauts went to the moon, they actually put little reflectors on the moon. So at McDonald Observatory out in far west Texas, they built a giant laser they fired at the moon. And so we know exactly how fast laser light travels, the speed of light. And so we know exactly how long it takes light to how long it took, because we measured it to a fraction of a second. And so from that, we could figure out the exact distance to the moon. And we find that indeed the moon is receding from Earth about 4 centimeters, about 1.5 inches per year. Now, the interesting thing is, this was actually predicted a long time prior to this, centuries earlier, by George Darwin. That's actually Charles Darwin's son. And so he figured out that with the Earth rotating slightly faster than the moon, that would make the tidal bulge just a tiny bit in front of the moon, pulling the moon forward, which would mean it would spiral outwards. Now, he got the actual size of the spiraling entirely wrong. He thought it'd be spiraling much faster than it currently is. But the basic idea that this would happen, he figured out. And so that's not really related to the impacts on the moon, but it does indicate that the moon's orientation with respect to Earth has slowly changed over time. And it is important to note that that millions of years ago, billions of years ago, in fact, the moon actually was quite a bit closer to Earth than it currently is because of this. It's been slowly spiraling outwards just a little bit at a time. And when it was closer, it was actually spiraling out even faster than it is now. So now that we're going to keep that in mind, because that actually has a lot to do with some of the ideas about the moon.